So good morning, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. And before I dive in with what we're all about, I just need to say it's great. You know that you're in for a good session when literally the guy we chose to begin our hype pump-up video is the guy who's talking today. So you're in for a treat. It's going to be a really fun time. So if you're new to this, we are all about bringing conservation, adventure, and science into classrooms around the world. I've been saying it since we started the school year, but I want to send out a huge thank you to all our teachers joining live on YouTube, wherever you are. I know it's been a crazy 8 months, and we really appreciate you spending time in your first few weeks back with us as we highlight amazing people and places. So September was insane, 52 programs in 16 days. But we're diving headlong into October with some really awesome sessions to kick off the month. So George Kourounis is, I think he might have done one of our first ever sessions, and he's done 30 plus since then. We've gone to the Crystal Caves in Mexico. We've gone to the Pit of Hell in Turkmenistan. We have gone all over the world in pursuit of amazing stories with George over the last few years. And today he is going to dive in with the science of some of the world's weirdest weather. So for our live classes that are here, for all our groups joining on YouTube, do let me know where you're tuning in from. Buckle up. I'm going to bring in George, and thanks so much for joining us today, George. I'm so excited. Let's do this thing, man.
Hey, Jesse, so good to see you. You know, it was hilarious that you play that video at the beginning, and the very first frame is me standing inside the volcano in the South Pacific. So
as one does.
As one does. Well, maybe not. Don't try this at home, I suppose, right? Well, thank you so much to everyone who's tuning in today all over North America and beyond, wherever you happen to be. My name is George Kourounis. I'm an explorer who specializes in documenting extreme forces of nature. And one of my titles is Explorer in Residence with the Royal Canadian Geographical Society. So I help to educate people about geography, nature, the natural world, and for me specifically, extreme parts of nature. So things like volcanoes and tornadoes and hurricanes and that kind of stuff. What I have for you today is all about weird weather. Like, tornadoes are weird, but we're going to talk about stuff that's super weird. So I'm really excited about this. There's some really bizarre things out there that you may have never even heard of. So our world is a wild place. So let me start sharing my screen here so we can get rolling right away. Share my screen, and then I go here, and I go here, and I hide this. Oops, I think I screwed it up, Jesse.
That's okay. That's half the fun. There has to be some sort of misclick. Usually it's me, so I appreciate someone else taking charge today.
I share the screen.
Yeah.
And then I go here, and I should hit hide, right?
Perfect. You got,
and then put it away. I'm just going to leave that up.
Just leave hide up. It's not working today. Sorry about that.
It's okay. No, you guys aren't seeing that yet. Hold on. Sorry, guys.
What I'll do, too, for all our students joining in is link to some of George's other presentations throughout the broadcast in the YouTube chat bar and in the comment section, so you guys can check those out. Literally, when you're done this session, you should just go and watch more of George's, because it will be the best few hours of your life. All right.
Just ignore where it says stop sharing at the bottom, because that seems to be causing me some problems today. But anyway.
Perfect.
We're good? Good. Yeah, so I work with National Geographic sometimes. I work with the Explorers Club a lot, Discovery Channel, the Weather Network. You may have seen me on television. I do a lot of TV work, chasing tornadoes for over 20 years across all parts of the U.S. I know we've got some people tuning in from Texas. I spent a lot of time in Texas chasing tornadoes, hurricanes, all over the world, Hurricane Katrina, you name it. And a lot of time descending down inside volcanoes, like you saw at the beginning of that intro video. So just that to give you a bit of an idea of the kind of stuff that I do. And getting on to the weird stuff, let's talk a little bit about lightning. I did a whole presentation, which I think Jesse's going to link to, about weird lightning. And I live here in Toronto, Canada, and we've got the CN Tower, and the CN Tower gets struck by lightning between 70 to 100 times every single year. And each bolt is 5 times hotter than the surface of the sun. So that's bizarre in and of its own, but things get much weirder. So along with, of course, these thunder and lightning, you get tornadoes that spin. A tornado is the part of a storm that rotates and touches the ground, this violently rotating column of air. And the United States gets about between 800 to over 1,000 every single year. And as a matter of fact, the US gets 75% of the world's tornadoes. And the vast majority of them, 99.99% of them, turn counterclockwise. So if you're looking at a tornado, it's going to be rotating from left to right in the northern hemisphere. If you're in Australia, they rotate clockwise. I had to think about that for a second. So if you're looking at it, it would rotate from right to left. And that all has to do because of the Coriolis effect. That's the rotation of the Earth. So as the Earth is spinning, that rotating force has an effect on these storms. These storms are so big that the rotation of the Earth will help to steer them in a certain direction. But every now and then, we get one in the northern hemisphere that spins the wrong way, about 1 in 1,000 or so. This is a picture I took in Kansas a couple of years ago. And there's 2 tornadoes on the ground at the same time. The one on the left, the bigger one, is spinning the proper direction, but the one on the right, the little one, is spinning in the opposite direction, the wrong way. Physics tells us that it shouldn't spin that way, but yet every now and then they sometimes do. And what happens is, it's really kind of cool. So imagine that these 2 tornadoes here, you're looking from above, and that's the big tornado in the middle there and the small tornado on the right. And you have this air that comes in between the areas of rotation and sort of spins around. If you've ever been canoeing or kayaking, you know that if you put your paddle in the water and draw it back, you form these little swirls. Well, if you look at those swirls, they rotate in opposite directions. And that happens on a much larger scale as well when it comes to certain storms. So if the winds are just right, you can get a regular, we call it cyclonic tornado, and we can also get an anti-cyclonic tornado that spins the wrong direction. And that is super cool to see that out in the real world because they're so, so rare. But you can make a little mini tornado every time you're out in a canoe. You can even do it in the bathtub. Just put your hand in the bath water and just pull it really fast along the top of the water like it's a canoe paddle, and you'll see these bits of rotation spinning in opposite directions. Very, very cool. Now, related to tornadoes, we have waterspouts. This is actually a photo from Italy from about a week ago that I got from an associate. And when you have a tornado that forms over top of water, then we call it a waterspout. And they can actually form from a couple of different ways. Some of them are just a regular tornado over water. Some of them form from the water up, which is a pretty cool thing. This particular one happened at night. It was illuminated by this bolt of lightning beside it, so that makes it really beautiful. Very bizarre. And you get these warm water with colder air above it. And we know that warm temperatures want to rise up, right? Heat rises, we know that. And when you have a warm body of water, like let's say the Great Lakes, and I know there's a bunch of you from Canada here. Well, it just so happens that yesterday, today, and for the rest of this week, we've got colder air coming in, and we're under waterspout watches right now. There were waterspouts seen on the Great Lakes yesterday, and I'm expecting more to happen later today and especially tomorrow. So I might be down on the lakes trying to photograph these waterspouts if I can. They're really hard to see because they're so rare and weird. So that warm air right above the lake wants to rise up. If the winds are just right, they can spin as that warm air rises up and forms a cloud. And if the two connect, the cloud and the water, boom, you've got a waterspout. And there's been all kinds of stories in the past about, well, actually, hold on, I'm going to hold that thought. Not only can waterspouts occur, but sometimes you can get families of waterspouts. This is a real photo from the Gulf of Mexico. of, I believe, 1, 2, 3, 4, 5, 6 waterspouts in one frame. And this video, let me play the video. Here we go. This was taken from an oil rig. I'm going to zoom in. So you can get families of waterspouts. Super rare and super weird. One of the places in the world that gets the most waterspouts is Florida, specifically the Florida Keys. The water there is very warm and the conditions are just right. And I've been down to the Florida Keys chasing waterspouts down there, and by boat and by airplane, and they're just amazing to see these little slender tendrils of air and water. And of course, that rising air pulls water up, but it can pull other things up as well. There have been stories of fish raining down out of the sky and frogs, things like that. And we believe that they are the result of waterspouts sucking up vast amounts of water with fish in it, because it's powerful enough to lift up these fish and then throwing them great distances. So you could be somewhere inland and not even that close to the water, and fish could start falling out of the sky because a waterspout nearby sucked them up and then launched them to your location. And this is a phenomenon that does happen. It's super rare and super weird, but it does happen. There's been documented evidence of this, so super bizarre. All right, on to the next weird weather. I'm going to play you a video, and I want you to see if you can figure out what's going on. I'm not going to tell you much about it other than this is from Saudi Arabia, a very dry desert country. It looks like the sand is moving. These guys have never seen anything like this before. You can see they're out in the desert. Not much around, but yet right beside them, the whole desert is on the move. Okay, so what's going on here? Well, there was a storm that happened, a big storm, far away from where these guys are. And that storm dumped a lot of hail. Billions and billions of hailstones, these little bits of ice that fell out of the storm. And now they're flowing downstream in this little creek. So it's a bit of a flash flood filled with billions of hailstones. There you can see them now. But because the hailstones pick up sand and dirt as they travel through the desert, it takes on the color of the sand that's around them. So at first glance, it looks like the desert is alive and all of this sand is on the move, but it's actually a freak, bizarre, unusual hailstorm in the desert in Saudi Arabia. Super bizarre, extremely rare, and they just happened to catch that on video. I love it. I love all this weird stuff. Now, let's combine some weather, or some not necessarily just weather, but let's combine a few different forces of nature, shall we? So let's combine lightning and volcanoes. As a matter of fact, volcanoes can make their own lightning. And this photo I took in Indonesia a few years ago. And this is an eruption of the volcano called Anak Krakatoa. And what's happening is all of the bits of volcanic ash. Volcanic ash, it's not like the kind of ash that you get when you burn wood. It's, imagine tiny microscopic pieces of rock, almost like glass, that get fractured and exploded out of the volcano. They rub together. Imagine dragging your feet across the carpet and touching a doorknob, right? You create all this static electricity, and when you touch the doorknob, it now releases that electricity in this discharge of a spark. The exact same thing can happen in volcanic eruptions. So all these trillions of of ash particles rubbing together create this static electricity, which then can, boom, cause lightning. And sometimes it can be really spectacular. Here's a couple of examples of really spectacular volcanic lightning. So imagine you're hiking somewhere and this volcano erupts. Not only is that crazy and just obviously very dangerous, but you could theoretically be struck by lightning that comes out of an exploding volcano. It's a rare phenomena. I've been documenting volcanoes for almost 20 years now, and I've only ever seen it once. But it does happen, especially with larger eruptions. The bigger the volcano eruption, the more likely it is to have lightning in it, just because there's so much more power there. Okay, we got a couple of more phenomena here, then we'll start taking some questions. Here's one very local here in Toronto, where I live, on the shore of Lake Ontario. It gets really cold in the winter time. And when it drops down to about minus 20 or so Celsius, we get these beautiful ice formations that happen on the shore of Lake Ontario. So we've gone from hot to cold now. And sometimes these ice formations do some really weird things. I don't even know what to call this. I discovered one of these about a year, not last winter, but the year before. I found a few of them. And I call it like an ice onion, because it kind of looks a bit like an onion. But it's an icicle. So the rocks that you see in the background, the sun warms the rocks. You got very cold air. The water is still not quite frozen, at least parts of it. So the water splashes against the rocks. It drips down, forms an icicle, and then that icicle reaches the surface of the lake, and the lake waves are heaving up and down. And so the bottom of the icicle gets fat and thick while the top doesn't, but it's still strong enough to hold it in position. And they form these bizarre ice sculptures that you would never imagine physically possible. So I can't wait for it to get cold again so I can go back to this exact spot so I can try and find some of these again. It's really amazing, these abstract sculptures that can happen in the ice just because of these perfect little conditions that happen to come up basically from time to time. But it's got to be really cold, and it's better if it's earlier in the winter, because then the water on the lake isn't completely frozen over. So you need that liquid water and the waves to go and accumulate all of this ice on the bottom of these icicles. A couple of more weird phenomena. It looks like some giant spotlights are shining up into the sky, right? This is a phenomenon that we call crepuscular rays. Actually, these technically are called AntiCrepuscular Rays. And as you can see, that there's a storm in the background. And if you look at the shadows, look at the grass. The shadow is pointing away from the camera. So that means the sun is behind us. So what you're seeing are these beams of sunlight that are illuminating dust that's in the air. And those light beams are basically firing and shooting away from us, but they look like they're coming together. If you've ever stood on a railroad track, which I don't recommend doing, it's not totally safe, but if you're supervised and there's no train coming, then if you stand on the railroad tracks and you look down the tracks, it looks like the tracks eventually come together in the distance, but they don't, right? It's an optical illusion. So imagine these beams of light are similar to railroad tracks. They're actually perfectly parallel. They're moving in a straight line, but they look like they're coming together in the distance. It's a really cool sort of optical illusion that's quite rare. And on this same day, this was the same day that I saw the backwards tornado in Kansas. As the storm was eventually leaving towards sunset, we got this interesting display. And then about a half an hour after seeing this, the sky looked like this. These are mammatus clouds. And when you go higher up in the atmosphere, it gets colder and colder and colder and colder. So the bottom of the storm will have lots of rain and liquid water suspended in it. But as you go up higher, up to the height of Mount Everest, these storms are absolutely massive, then the air is so cold that all that water freezes into ice crystals. And the storm can only go up so high. So at the very top of these thunderstorms, the air is actually bouncing off an invisible layer in our atmosphere that it cannot go any higher than. And some of that air sort of descends back down, forming these beautiful round pouches in the very high atmosphere. And when the sun is setting, it gets lit from below, and you get this beautiful orange sunset with these globular pouches underneath the top of the storm. Really beautiful to see. It's not necessarily, there's a bit of a myth that if you see this, it means that there's a tornado, but that is not necessarily true at all. It just means that there's a thunderstorm and you're seeing it lit up by the sunset. All right, I think we got one more thing I want to talk about, and it has to do with fires. So remember before we were talking about lightning and volcanoes. Well, forest fires do some really interesting things. And unfortunately, we've had some really bad fires this year in Australia, where this photo was taken. I was in Australia a couple of years ago with some firefighters. Australia has had some just terrible, terrible fires. But then, of course, just recently in California and in Oregon, the fires have just been absolutely devastating. And of course, as our climate continues to get warmer, the conditions for these wildfires are going to continue to get bad, and we're expecting more and more of them. But an interesting thing that happens with wildfires is that they generate a lot of heat. Aha. So what does heat want to do? Heat wants to rise, right? So that rising heat from the from the forest fire can pull all kinds of moisture from the air up with it. That moisture eventually gets up to an area in the atmosphere where it's cold enough that it turns into clouds. So you can have clouds that are formed by fires. And that's what we're seeing here. Notice we've got the fire at the bottom. You can see all the smoke. You can't really see the fire too well, but you can see the smoke coming up. And then at the very top of the frame, you've got these really white clouds. So the fire is creating clouds. Okay. So if you have a really big fire, you could create some really big clouds. So these clouds, we call them pyrocumulus clouds. Pyro meaning fire, cumulus meaning low-level cloud in the atmosphere. But if it gets big enough, you can actually create something called a pyrocumulonimbus cloud, which is basically a thunderstorm. So you can have thunderstorms that are created by fires. So the fire gets that warm air rising, the smoke and heat rise up, it cools down, forms a cloud, and then just like a regular thunderstorm, you can have rain that comes out, which is good if you're trying to put out a fire. But you can also have lightning that comes out of the thunderstorm created by the fire. And that's a big concern because lightning strikes can create even more fires. So imagine that. You're a firefighter trying to fight this fire. It's creating a storm that's producing lightning that's creating more fires. So it can become this cycle, this self-perpetuating cycle. But let's take this one step further. Okay, so what if you have a fire that's big enough to create a cloud, the fire gets big enough to create a thunderstorm cloud, but what if that thunderstorm cloud starts to rotate as well? You can actually have a fire that creates tornadoes. And for the first time ever, earlier this year in California, the National Weather Service issued a tornado warning for one of the forest fires that was happening in California, because the winds were just perfect to cause that rising air to rotate and form an actual tornado within the forest fire. And it is probably one of the scariest things I could possibly imagine. You got the power of an actual tornado ripping trees out of the ground and throwing cars, and the whole thing is happening in the middle of a forest fire. And I've got a little video clip here from some of the firefighters who witnessed this. The quality gets a bit better. There we go. You can see it spinning. So there's the fire, all the embers burning, the sirens are blaring, and you can see the tornado in there. Now take a closer look. Which way is it rotating? right to left. So this is one of the rare anticyclonic tornadoes. So this is probably one of the most rare weather phenomena in the world. We have a tornado created by a wildfire that is spinning the wrong direction. So it's got all of the ingredients to make it the weirdest, wackiest, and one of the most frightening weather phenomena out there. Crazy. Okay. So I've got so many photos and everything online. FuriousEarth.com is my my website. You can go there. There's links to a YouTube channel that has all kinds of video clips of every kind of weather and volcano and that you can think of, every natural phenomena out there. So there's just a few. I could have gone on with a list a mile long, but it's always amazing to me with the variety that we have in our atmosphere here on Earth. We're very lucky that the Earth has provided us with the conditions to live and and have so many different species and biodiversity. But at the same time, those conditions can create some really unusual aspects. And now that everybody has a camera on them, we're able to document these better than we ever could because everyone's got a camera now. So we're seeing things that we didn't know existed before, which is super cool.
It is. Actually, I want to lead off with the first question before we dive in. We got over 160 kids on YouTube as well, so it's just a packed, crazy day. 250 plus students from around the world. George, how do you get any work done? How do you not just stand slack-jawed and just like gaze at all these amazing things? This is like some incredible stuff. Like, how do you see this when you go to these places? Do you see people actually like admiring this weather with you, or is it just the professional teams out there? Because it's wild.
All the time. Like I'll spend a tremendous amount of time and effort trying to be in a particular spot to witness the tornado, for example. And there's always going to be someone next to me, some farmer, some local person who's got their cell phone because they just happened to be there when it was happening, right? By total coincidence. And it's these coincidences that really allow us to learn quite a bit because everyone has a camera. So it's kind of cool that we're getting these glimpses from what I call citizen video. But at the same time, I put a lot of work to go to these places, a lot of effort, a lot of time, and a lot of money. And, it's it's what it is.
Well, you can tell the story better. As we heard today, it's some pretty cool stuff. So I want to go to Miss Gross's class, joining us in San Antonio with just a bevy of grade 2 students. So Miss Gross, if you want to kick us off with a question, come on in.
Yes, hi. We have a couple questions. Can you tell me what is the largest number of water spouts that you've seen together with that phenomena? And then the other question was, can you show us a picture and explain what a reverse tornado is?
Yeah. In terms of the number of most water spouts I've ever seen at once, I think it was 3, if I remember correctly. It was in Key West in Florida. That was impressive. Reverse tornado. Here's the thing. A reverse tornado, or we call it an anticyclonic tornado, and a regular cyclonic tornado look the same. If you were to look at a still picture of one, it's impossible to tell the difference between the two. They look exactly the same. If you're watching video of them, or if you're seeing it in person, that's the only way that you can tell that it's rotating the wrong way. Because a still image doesn't really show you which way it's rotating. It's like a figure skater. If a figure skater is spinning and you see a still picture of them, it's hard to tell which way they were actually spinning. But if you were to watch the video, then you can tell. So what I do recommend is hop onto YouTube and do some looking for reverse tornado, or anticyclonic is the proper term. And you'll see some pretty good examples on there.
Yeah, which we got with the fire tornado too, which is super cool, by the way.
Yeah, exactly. You could see it with the fire tornado. You could see it rotating from right to left.
Yeah. Whatever way we can try and do through the camera, the reverse camera. But that was great. And by the way, for all our students tuning in, I will link, you know what, I'll bring it up right now. George's Lightning Talk, Thunderbolts and Lightning on our YouTube channel. Check that out when you're done. It probably had the most other unique footage of any talk we've ever done with George, so it's really amazing follow-up. I want to go to Miss Hood, joining us in Ackland, Pennsylvania. Miss Hood, if you want to come in and ask a question, go for it.
Hi, thanks for having us. I have a question from two of my students. They happen to be siblings, Gabriella and Amelia. They did some research on Mr. Kourounis and want to know if he was scared when he went to the Darvaza Crater.
Okay. The short answer, yes. The long answer, let me explain, because not everyone knows what that is. So Darvaza is a, Jesse, while I'm talking, can you pull up a picture of Darvaza for me, if that's possible?
I sure can, and I can also put it on the screen like that where people can find it. So you start talking, and I'll pull it up as quick as I can.
Preferably one with me in it, if you can.
Okay.
So it's a crater in the desert of Turkmenistan, which is in Central Asia, just north of Iran. And it's a pit about 100 feet deep and 230 feet across that was accidentally caused when a natural gas drilling operation, there we go, when a natural gas drilling operation collapsed and they lit it on fire, and now it has all this burning methane gas coming out of it. It's been burning for almost 50 years. And so I led an expedition for National Geographic to go there and become the very first person to ever go down inside this burning crater. So I had special heat protective suits. I had my own air tank. And it took about 2 years of planning and preparation to get everything in place. And the reason was we wanted to look and see if there was any kind of bacteria living in the soil in the bottom of this hot, burning hot, it was hotter than a pizza oven, hot crater filled with methane gas, because there are planets outside of our solar system that have a similar kind of environment. So if we could find anything, any kind of microscopic bacteria living in the soil here, that could give us clues as to where we should look for life on other planets in the search for alien life. Not aliens like ET, alien like tiny microscopic bacteria. And we found some. So there's bacteria living down there. So that was really cool. I was able to spend 17 minutes at the bottom gathering soil samples and taking measurements and things like that. And I got a Guinness World Record. It's sitting above my desk for being the first person to ever go down inside that crater. So it was very scary. The scariest part was stepping off the edge of the crater and putting all my weight on the rope and then going out to the middle. I had some pulleys, so I was able to go out onto the rope and then rappel down right into the center of the crater. So go on to your favorite search engine and just type in Darvaza and you'll find it.
Outstanding. Thanks, George. I'm really glad we got a chance to highlight that. It's such an amazing place. All right. I want to take a question from YouTube now. So I love this question from Leah in Mr. Rutledge's class. If tornadoes can make holes in the ground, George?
If tornadoes can make holes in the ground, yes, technically, but I wouldn't call it a hole. It's more of a scrape, like a trench. So a very powerful tornado can go at over 200 miles an hour, close to 500 kilometers an hour. And that is so powerful and so strong that it can like rip trees out of the ground and scour the ground. But tornadoes don't stand still. They're moving. So a tornado will move at the same speed as the storm that created it. So you've got your storm here, it produces a tornado, the tornado is grinding up the ground, and as the storm moves across the countryside, it brings that tornado with it. So if you were to look at the path of a tornado after it goes through, if you're from an airplane or a satellite, you could see a dark line, like a scrape across the ground, and you can see exactly where that tornado went from when it was born until it dissipated. And that's how we sometimes figure out how long a tornado was on the ground for and how wide it is by looking at this scar that it created across the ground.
Yeah, fantastic. Thanks, George. All right, we're getting so many great questions pouring in on YouTube. Again, over 6 classes at least joining in on there. So thank you so much for all you guys tuning in from all over Canada and the States. I want to go to A.N. Meyer Secondary School, so let's go to Niagara Falls. Mr. Taylor's group, you guys have a question for us? Go for it.
Go for it. I was wondering what your favorite and most weird weather you've ever researched and why.
Ooh.
No pressure.
Ooh, yeah, no pressure. Seeing the volcanic lightning in Indonesia was pretty amazing. That was sort of on my personal bucket list for years and years and years. Interestingly, I was one of the people that documented and filmed the largest tornado that has ever been seen. It was in 2013 in Oklahoma. It was 2.6 miles wide. That's 4.3 kilometers. Absolutely massive. It just looked like a giant smudge, a dark smudge across the entire horizon. And that storm was unbelievably powerful and so big. No one had ever seen anything like it. And I was right behind it, following it. And I couldn't believe what I was seeing.
Yeah.
Scary.
Great question, guys. I think you've gotten that question 50 times in at least once a broadcast, sometimes multiple times, just for fun. And you know, you've had some different answers in the past. I love highlighting some of the amazing things you've got a chance to do. So check out Furious Earth Dark. Like, I mean, honestly, for all our students, check out George's website when you're done. I'll bring it up in a banner so it's on the bottom of the screen, and you'll learn and see a lot of even cooler things than you got a chance to do in this 20-minute presentation. I want to go to Miss Oster's class in Spruce Grove, Alberta. Welcome in, guys. Just demute your mic, and you're good to go for a question.
Does the fire go all the way to the top in a fire tornado?
Right. So, does the fire go all the way to the top in a fire tornado? No, it doesn't. So, there's a couple of different things that happen in fires. You can get these small, we call them fire whirls or fire devils. They're these sort of small, they look like mini tornadoes of fire. And those are pretty common. You know, on a hot day, when it's really, really hot and a blue sky, and you see what kind of looks like a tornado made out of dust, but there's no cloud above it, we call that a dust devil. So you can have those that form in these fires very frequently. But for the storm, or for the fire to create a storm that then produces a tornado, is extremely rare. That fire could go up maybe a couple of 100 meters, I would say. But it wouldn't go all the way to the top. Like, these storms are absolutely massive. The biggest storms are twice the height of Mount Everest, and there's no way the fire gets up that high. But that warm air will.
Fantastic. Great question, guys. Some really unique questions today, which is awesome. Classes in the first groups, too. Today is a good day. October 1st, great students. Thank you guys so much. So Mr. Clue, her class, Lily in Silver Creek School, wants to know, how much weird weather do you see in a year, and how often does such weird weather occur?
Oh, well, that's a great question. It totally varies. I spend, well, not this year so much, because I haven't been able to travel nearly as much as I would like to. But there have been times when I've traveled 220 nights a year, back when I was making the Angry Planet TV show. It's a show I used to host. And we would spend almost the entire year traveling all over the world, filming a television program. So it's kind of hard to say. This year I haven't had the chance to do much at all, but having said that, over the next couple of days, I am hoping to get down to the Great Lakes, which are not too far from me, to try and find some of those waterspouts.
Yeah. By the way, since we both live in Toronto, if you ever see any of that cool ice onion stuff, you just call me and I'll come and check that out, because I've never seen anything like that. That is wild. Waterspouts, too, I had no idea happened on the Great Lakes. So that's super cool.
Well, Jesse, hold on. I'm going to interrupt you there for a second.
Please.
Because on the days when I find those ice onions, it's the same days when we have the really cold temperatures on the lake, and in the morning, right at sunrise, you get a layer of steam coming off the lake. Okay. And the steam can sometimes form these swirls. So you get these steam devils, these little mini tornadoes out of steam that are dancing across the surface of the lake if the winds are just right. And that's what I was trying to find on the day that I found the ice onions.
Yeah.
So there's some really amazing stuff that happens, but you have to be an early bird to see it. I
was going to ask, how early in the morning is this that you have to be out on the lake?
You're there when the sun comes up.
Okay. Yeah. Good to know. Please do. All right. Let's take a couple questions from YouTube. We'll see if we can take some from our classes live again. But Miss Nilvo's grade 3s in New Mexico, Los Lunas. Welcome in, guys. Largest tornado in the world we've covered. How do you not get hurt doing these things?
Excellent question. So in over 2 decades of doing this, not a single broken bone, not a single overnight stay in hospital from any injury. So I've gotten sick a lot while traveling, caught dengue fever, and I've had all kinds of illnesses while traveling, but I've never been injured by any of these phenomena. And the reason for that is safety is always the number one concern, right? Yes, I want to get these shots, and yes, I want to document these things, and I frequently work with scientists to gather samples and things from difficult and dangerous places. But none of that is worth dying for. So safety is always number one. I do a lot of research and reading and studying beforehand, because you can't go to school for this. I have to do this all on my own. So all that research, I work with good people who are equally smart and who are watching my back while I'm watching theirs. And having the right equipment and just working, studying and learning from people who have been more experienced than me. So all of these little things add up to make it as safe as possible. Yep. Will it ever be 100% safe? No, of course not. I chase tornadoes and climb inside volcanoes. But what I do is try to minimize the amount of risk, right? So that's important. And every single time I have rules that I set with my team. Yep. Anyone can call it off at any time for any reason if they feel it's unsafe. So even if I think it's safe and my teammates don't, then we stop. It's that simple.
The only other person that we have on the broadcast that sort of consistently does as dangerous potentially stuff as you is Jill Heinert, who I know you know well. So a lot of people ask her about sort of her fear and preparation going into things. And I mean, one of the things with these jobs is that they are so inherently dangerous. They can be so inherently dangerous that the prep is so important. And being cognizant and having respect for the sort of phenomena that you're covering and the situations you're getting yourself into is huge. So I'm really glad we get that question every time. And so thanks so much to our student for that. I want to see if we can take two more questions from our live groups. Miss Hood's class, if you want to come back in, go for it.
Hi. So I have a kind of a lumped together question. So we see that your title is Professional Adventurer. So how does one become a professional adventurer? And also, what other kinds of career type people do you work with frequently?
Fantastic question. Yeah. So this is basically what I do for a living. And a lot of that has to do with working in television. So I do a lot of appearances on television. As a matter of fact, tonight you're going to be able to see me on Science Channel on a TV show called What on Earth? I forget what time, but check your local listings. So I do a lot of work with TV networks, the Weather Network, Science Channel, whatever, right? So that's one aspect of it. I also am able to sell my photos and videos to various filmmakers and books and things like that, textbooks, use my images for things. I spent 12 years working as a tornado chasing tour guide. So part of my tornado chasing was supplemented by bringing people with me to go and chase these things. So there's various different ways. The Darvaza gas crater expedition with the pit of fire, that was funded by a science grant from National Geographic. I also do a lot of talks. I give talks to companies and libraries and schools and things like that. So a lot of it has to do with going out and documenting these things, but also sharing what I've seen. And it's that sharing part that has allowed me to make income that allows me to go out and do the things, right? So it's a twofold process. Yeah.
Thank you.
And people that I work with. So I work with a lot of television producers and cameramen. I work with a lot of scientists. I work with tornado researchers from California, National Geographic, of course. I work with the Canadian Geographical Society, all kinds of interesting people from all different fields and areas. Volcanologists, mountain climbers, you name it. It's fun. I've met some cool people.
George does not stop, is the moral of the story. He just keeps on going, and there's some really cool stuff. I want to mention, too, Angry Planet, which you mentioned. I'm pretty sure is on Amazon Prime, and I'm just checking this out right now. So if people want to check out your show, I think you can stream it still on Amazon Prime, which is...
It's on Amazon. Yeah, Angry Planet, my old TV show, is on Amazon Prime, and they're about to start re-airing some of the older episodes on the Weather Network here in Canada starting October 10th.
Fantastic. Cool. So check it out in all sorts of which ways. We're going to go to Miss Oster's class for one last question. They were having a dance party a minute ago. Don't know what's going on. They're just crazy excited. So Miss Oster's group. Hey, guys, welcome in.
No, I had a question. there's water spouts and they can lift up fish and frogs, can they lift up other things like seaweed, other things that live in the ocean?
Yeah.
Right. So could a water spout pick up other things other than water and maybe some fish, things like that? Seaweed, sure, absolutely. Why not? Anything that is light enough for those powerful winds to pull up could be pulled up with it. Yeah. So there's been stories of frogs coming down out of the sky. Certainly seaweed would be a possibility. Yeah, absolutely. There's no reason why that couldn't happen.
Fantastic, George. Well, again, time flies when we're having fun. We're at the 45-minute mark. So is there any last message you want to share with kids about your own journey, how they can get involved and sort of tracking exciting weather and nature phenomena, or what would you recommend to kids?
Yeah, so if you're interested in maybe witnessing some of these things, spend more time looking up as opposed to looking down, right? There's in the morning, early morning, and around sunset, that's when the sky puts on the most interesting show. If you're near the ocean or if you're near one of the Great Lakes, those are great places to see weird and wacky weather that are not necessarily dangerous, but interesting nonetheless. And when you see on the weather forecast that there might be a storm coming in, then maybe watch the sky a little more around those times. Do it safely. Don't go outside, stand next to a tree during a thunderstorm because you could get struck by lightning. But from your porch or wherever is safe, you're going to see some really cool stuff that you'd be amazed to see that you don't notice if you don't look up.
Fantastic. It's funny how many of our speakers, regardless of the topic, the message boils down to be observant, whether it's looking out for storms or looking down for bugs for our entomologist speakers that come in. Just, engage with the world around you. One of the things we did all September long was backyard bio, encouraging kids to get out in pursuit of nature. Really, really successful, lots of fun. So get out there, enjoy the world, and stop taking pictures of storms when you're there so that George can go and bring his cooler camera and his cool
No, take your camera. Take some pictures. Put them on Instagram. Put them on Twitter. I want to see them. I want to see them, right? Documenting them. Documenting this stuff is an important part of science, right? Yeah. If you're not writing stuff down or documenting it, then you're just messing around. If you do, that's how science works.
Fantastic. Well, George, it's always such a pleasure having you. What we're going to do, like at the end of every broadcast, I'm going to bring in our teachers that could stick around to the end. So Miss Hood, Miss Oster's class, if you want to say a big thank you and goodbye to George. Thanks so much for joining us today, guys. Bye, everyone.
Thank you.
We'll see you all soon.